Question 1. The core principles of NSST logical switches emphasize isolation and scalability. Imagine a multi-tenant cloud provider hosting multiple customers, each requiring isolated L segments that can scale across different racks without VLAN limitations. Which approach best leveraged NSST to achieve this while maintaining flexibility for workload mobility and integration with existing VLAN-based networks? A. Create VLAN-backed logical switches for each tenant and interconnect them using centralized routers. B. Deploy overlay-backed logical switches using Geneva encapsulation to provide tenant isolation. C. Use physical VLANs on top of rack switches and extend them with Layer 2 bridging for isolation. D. Implement distributed firewall rules between workloads without segmenting the underlying network. Answer. Correct answer. B. Explanation. Overlay-backed logical switches in NSST using Geneva encapsulation decouple logical topology from physical constraints, enabling multi-tenant isolation and scalability beyond VLAN limits. VLAN-backed switches A. Remain tied to physical VLAN limits. Layer 2 bridging. C is for extending VLANs, not for scalable isolation. Distributed firewall rules. D. Secure workloads, but inherently segment L networks, making overlays the optimal scalable isolation mechanism. Question 2. During the process of troubleshooting NSST overlay network connectivity between VMS on different hosts, you discover VMS can communicate within the same host but not across hosts. Tunnel endpoints (TEPs) appear unresponsive between SXE nodes. Which step is most likely to resolve the issue based on NSST architecture? A. Verify that the TEP IP addresses are on the same VLAN and that physical network MTU supports Geneva encapsulation. B. Replace overlay-backed logical switches with VLAN-backed switches to bypass tunneling. C. Configure static routes between TEP IP addresses to bypass underlay routing protocols. D. Disable the distributed firewall to rule out east-west filtering as the cause. Answer. Correct answer. A. Explanation. TEP communication requires correct VLAN configuration and sufficient MTU, typically 1600 plus, to handle Geneva headers. VLAN-backed switches. B. Avoid overlays, but remove their benefits. Static routes. C. Are rarely needed. SD relies on dynamic underlay reachability. Disabling the distributed firewall. D. Doesn't fix TEP reachability issues, as the firewall operates at the VM level, not the transport tunnel. Question 3. When analyzing NSST distributed routing, you observe that traffic between two VMS on the same host but in different subnets never leaves the host. What underlying principle allows this efficiency, and why is it significant for performance? A. Centralized control plane processing routes entirely within the NSST manager cluster. B. Physical routers handle inter-subnet communication directly on the underlay network. C. Distributed routing on each hypervisor processes routing in kernel, reducing latency. D. Logical switch replication eliminates routing and relies solely on L broadcast domains. Answer. Correct answer. C. Explanation. Distributed routing places routing logic directly on each hypervisor's kernel, enabling local inter-subnet communication without sending traffic to external devices. The control plane A. Pushes config, not traffic. Physical routers. B. Add latency and underlay dependency. L broadcast reliance. D. Doesn't address routing at all. This design minimizes latency, avoids bottlenecks, and improves scalability. Question 4. Across different scenarios of hybrid environments, NSST must bridge logical overlays with physical VLANs for workloads requiring bare metal integration. What is the most effective method to achieve seamless connectivity while minimizing complexity? Configure Layer 2 bridging between an overlay segment and a VLAN-backed segment. B. Assign VMS dual NICs, one on overlay and one on VLAN, to handle hybrid traffic. C. Use centralized edge routing with NAT to translate between overlay and VLAN spaces. D. Manually replicate MAC address tables between virtual and physical switches. Answer. Correct answer. A. Explanation. Layer 2 bridging in NSST allows an overlay segment to share the same broadcast domain as a VLAN-backed segment, enabling seamless connectivity. Dual NICs. B. Add operational complexity. NAT-based routing. C. Breaks L adjacency, impacting certain applications. Manual MAC replication. D. Is not scalable or supported. Bridging keeps broadcast and AL communication intact while preserving NT flexibility. Question 5. Given the circumstances of a security audit requiring strict isolation between application tiers but without disrupting existing network design, which NSXT feature most effectively enforces microsegmentation at the VM level regardless of network topology? A. Distributed firewall with security groups based on VM attributes. B. Gateway firewall filtering all north-south application traffic. C. Logical router policies controlling east-to-west communications. D. VLAN-ACLs configured on physical switches for each tier. Answer. Correct answer. A. Explanation. The distributed firewall applies at the hypervisor level, allowing granular microsegmentation between workloads regardless of underlying topology. Gateway firewall. B. Targets north-south, not intra-tier isolation. Logical router policies. C. Offer routing control but lack deep level inspection. VLAN-ACLs. D. Require physical changes and lack the dynamic flexibility of NSST security groups. Question 6. Through careful analysis of NSST edge nodes, you identify they are essential for certain functions but not for others, in which case is deploying an NSXT edge node mandatory? A. Implementing distributed firewall microsegmentation between workloads. B. Enabling north-south routing between overlay segments and external networks. C. Configuring overlay-backed logical switches for east-to-west VM traffic. D. Assigning VMS to security groups for distributed policy enforcement. Answer. Correct answer. B. Explanation. Edge nodes handle centralized services like north-south routing, VPN, and load balancing. Distributed firewall. A. Overlay-backed switching. C. And security group assignments. D. Occur at the hypervisor without edge involvement. Without edge nodes, overlay segments cannot reach external networks, making them critical for external connectivity. Question 7. To determine whether an SST can meet a disaster recovery objective, an architect assesses backup and restore capabilities. Which statement most accurately reflects best practice for NSST configuration backups? A. Backups should be stored only on the NSST manager to ensure quick access. B. Automated backups should be scheduled to a secure external location supporting encryption. C. Manual exports before each configuration change are sufficient for doctor readiness. D. Configuration backups are unnecessary if the vCenter server database is backed up. Answer. Correct answer. B. Explanation. Best practice is to schedule automated encrypted backups to secure external locations for resilience. Storing only on NSXT Manager. A. Risks lost during failure. Manual backups. C. Are inconsistent. vCenter backups. D. Don't capture NSXT's unique network and security configurations. External backups ensure recoverability in disaster scenarios. Question 8. From a practical standpoint, a network team wants to monitor NSST health without deep packet inspection. Which built-in NSST feature is most suitable for ongoing operational visibility into logical network performance? A. Traceflow to capture and analyze live packet payloads. B. Port mirroring to send traffic to an external monitoring tool. C. NSST Manager dashboards and alarms for real-time system health. D. CLI-based packet capture on each hypervisor for periodic reviews. Answer. Correct answer. C. Explanation. NSST Manager dashboards and alarms offer integrated, real-time health and performance monitoring without packet inspection. Traceflow is for path tracing, not continuous monitoring. Port mirroring. B. Offloads to external tools and increases complexity. CLI packet capture. D. Is reactive and not scalable for proactive monitoring. Question 9. When considering role-based access control RBAC NSST, a large enterprise wants to ensure that help desk staff can view but not modify firewall rules. Which RBAC configuration achieves this requirement? A. Assign the enterprise admin role to help desk staff with read-only vSphere access. B. Create a custom role granting read-only permissions to security policies. C. Assign the network engineer role, which includes firewall modification rights. D. Use the auditor role, granting both read and modify permissions for firewall objects. Answer. Correct answer. B. Explanation. Custom roles in NSST can be tailored to grant read-only access to specific objects like security policies. Enterprise Admin A grants full rights. Network Engineer C has modification permissions. Auditor D in NSST is not inherently read-only for specific objects. Fine-grained RBAC ensures principle of least privilege. Question 10. Examining the consequences of MTU misconfiguration in NSST overlays, a migration project observes intermittent packet drops between workloads. What is the primary underlying cause in this scenario? A. Physical switches blocking GNIV traffic due to ACL mismatches. B. MTU too small on the underlay network causing fragmentation or drops. C. Logical switch misalignment between VLAN and overlay configurations. D. Excessive CPU usage on hypervisors due to over-provisioned VNICs. Answer. Correct answer. B. Explanation. NSST overlays require higher MTU, commonly 1600 plus, for GNIV encapsulation. If underlay MTU is too small, packets fragment or drop, causing performance issues. ACL mismatches can block traffic but are unrelated to MTU of LAN overlay misalignment. C. Impact connectivity differently. EPU over U. D is a performance, not MTU issue. Question 11. In light of recent developments in data center virtualization, an NSST administrator must design a solution to support a multi-site deployment where logical networks span geographically dispersed sites. The requirement is to maintain low latency east-to-west traffic between VMS in the same segment while ensuring failover and continuity in case of site failure. With NSST architecture approach best satisfies these requirements. A. Use stretched logical switches with a combination of local and centralized routing to maintain local traffic flows and site failover. B. Deploy VLAN-backed logical switches only replicating VLAN configurations on each site with the NSXT overlays. C. Implement centralized routing on a single site's edge node and route all traffic through it for consistency. D. Rely solely on physical underlay routing between sites with the NSST overlay extensions. Answer. Correct answer. A. Explanation. Stretched logical switches allow NSST to extend layer 2 segments across sites using overlays, maintaining low latency local traffic processing via distributed routing on each host, while centralized routing handles cross-site traffic and failover. VLAN-backed switches B. are limited by VLAN scalability and lack overlay benefits. Centralized routing on a single site C. creates bottlenecks. Latency. Physical underlay routing alone. D. fails to provide the required LL extension and failover resiliency inherent in NSXT multi-site designs. Question 12. Based on the information from a recent security audit, the enterprise has identified that microsegmentation policies are not consistently applied across all virtual workloads. Some VMS can bypass distributed firewall rules when communicating through north-south traffic via the edge node. What configuration adjustment in NSST is most appropriate to enforce consistent security policies regardless of traffic direction? A. Enable the gateway firewall on the edge node in addition to the distributed firewall on hypervisors. B. Disable distributed firewall to force all traffic through the gateway firewall for inspection. C. Apply distributed firewall rules only to physical workloads outside the NSST environment. D. Use VLAN ACLs on the physical switches as a replacement for NSXT firewall policies. Answer. Correct answer. A. Explanation. NSST's distributed firewall applies microsegmentation at the VM level and east-to-west traffic, but north-south traffic through the edge node must be secured by enabling the gateway firewall. Disabling the distributed firewall. B. Undermines microsegmentation benefits, applying distributed firewall rules only to physical workloads. C. Ignores virtual traffic flows. VLAN ACLs. D. Do not provide the granularity or integration of NSST firewall capabilities. Question 13. Considering the evidence from a recent upgrade project, an NSST environment experiences unexpected asymmetric routing issues where packets between VMS traverse different physical paths, causing dropped connections. What configuration elements should be verified or modified to prevent this behavior? To ensure that the TPIP addresses have symmetrical routing paths and that the physical underlay supports ECM properly. B. Disable the distributed firewall to remove routing constraints within the overlay. C. Replace overlay networks with VLAN-backed logical switches to avoid tunneling issues. D. Increase the MTU and physical switches without adjusting TEP addressing. Answer. Correct answer. A. Explanation. Asymmetric routing can cause session drops because return packets take different physical paths. Ensuring symmetrical routing for TEP hips and proper EP support on the physical underlay maintains consistent flow and stateful connectivity. Disabling the distributed firewall. B. Is unrelated to routing paths. VLAN-backed switches. C. Limit overlay flexibility and don't solve asymmetric routing. Increasing MTU prevents fragmentation but does not address asymmetric routing. Question 14. The fundamental question is how NSXT achieves scalability and fault tolerance within its control plane architecture. An administrator wants to avoid single points of failure while ensuring consistent distributed system operation. Which design principle best illustrates how NSST control plane components maintain this resilience? A. The NSST manager cluster replicates state data across nodes and coordinates with transport nodes for distributed control plane functions. B. Control plane functions are centralized in a single physical NSXT manager appliance to prevent state divergence. C. Transport nodes operate independently without interaction with the control plane for maximum scalability. D. Logical switches are manually configured, each host without control plane synchronization. Answer. Correct answer. C. Explanation. While NSST Manager cluster replicates management state, distributed control plane functions run on transport nodes, SKI or KVM hosts themselves, providing scalability and fault tolerance by decentralizing routing and switching decisions. Option A incorrectly implies all control plane functions centralize in the manager cluster. B. Centralization creates a single point of failure. D. Ignores the NSST architecture entirely, which depends on synchronization for logical networks. Question 15. Through the lens of operational management, a network administrator is tasked with ensuring continuous monitoring and rapid issue detection in an NSST deployment. With NSST feature combination provides the most comprehensive proactive health monitoring and troubleshooting capability. A. NSST Manager's dashboard combined with trace flow and port mirroring for detailed packet path analysis. B. Manual packet captures on SXI hosts without centralized logging or alerting. C. Physical switch SMP polling combined with manual firewall rule reviews. D. Relying solely on vCenter server logs for network visibility. Answer. Correct answer. A. Explanation. NSST Manager dashboards provide real-time health and alerts. Traceflow allows simulation of traffic paths and port mirroring aids detailed analysis. Manual captures. B. Lack scalability in integration. SMP polling. C. And manual reviews don't provide NSST-specific insights, relying only on vCenter logs. D. Overlooks NSXT's unique control and data plane telemetry. Question 16. When faced with the challenge of integrating physical workloads that cannot run the NSST virtual switch, what is the recommended NSST solution to extend network virtualization features such as micro-segmentation and overlay connectivity to these devices? A. Deploy NSST bridge nodes that connect physical VLAN segments to NSST overlays via Layer 2 bridging. B. Configure physical firewalls to replicate NSST distributed firewall rules manually. C. Exclude physical workloads from NSST and secure them using traditional VLAN ACLs. D. Assign physical workloads to overlay-backed logical switches without any bridging. Answer. Correct answer. D. Explanation. Physical workloads cannot participate directly in overlays without bridging. NSST supports Layer 2 bridging A to connect physical VLANs to overlays, allowing micro-segmentation and connectivity. Manually replicating firewall rules. B. Is error-prone, excluding physical workloads. C. Reduces security consistency. Assigning physical devices directly to overlays. D. Is not feasible without bridging. Question 17. The predominant theory suggests that NSXT's use of Geneva encapsulation over VXLAN and GRI protocols offers distinct advantages. What key feature of Geneve makes it preferable in NSXT overlay networks? A. Geneve supports extensible metadata options, allowing for future feature enhancements without protocol changes. B. Geneve requires less overhead than VXLAN, reducing packet size significantly. C. Geneve is designed exclusively for physical switch interoperability, unlike VXLAN. D. Geneve does not require encapsulation and works at layer 2 natively. Answer. Correct answer. C. Explanation. Geneve is designed for extensibility with metadata, supporting a range of features like security tags and service chaining, making it more adaptable than VXLAN or GRI is correct in reality. Option C incorrectly states it is exclusively for physical switches, which is false. AirT's choice of Geneve is for its extensibility, not physical switch interoperability. Geneve has slightly more overhead than VXLAN. B. Geneve encapsulates packets at layer 3, so D is false. Question 18. In summary of an NSXT host preparation process, an administrator must ensure SXT hosts are properly configured for NSST deployment. Which step is critical to enable hosts to participate in NSST overlay networks and distributed routing? A. Installing the NSXT VIBs vSphere installation bundles on the SXT hosts. B. Assigning static IP addresses to all VMS connected to NSST logical switches. C. Disabling the VMware distributed switch to prevent conflicts with NSST. D. Manually configuring VLAN trunks on the physical NICs of SXT hosts. Answer. Correct answer. A. Explanation. NSST VIBs provide the kernel modules that enable SXT hosts to handle overlay encapsulation, distributed routing, and firewalling. Assigning static IPs to VMS B is not required for overlay networking. Disabling VDS-C is unnecessary and counterproductive. SD can coexist. VLAN trunking D is a physical network task, not directly part of host preparation for NSST. Question 19. Given the circumstances of an organization deploying NSST with multiple teams managing security policies, how does NSST ensure that RBAC enforces least privilege access while allowing flexible policy management? A. NSXT supports granular role-based access control that can assign permissions per object type and per user or group. B. NSST allows only 2 roles, administrator and viewer, limiting flexibility. C. NSST delegates all access control to the underlying vCenter server roles. D. NSXT requires manual configuration of firewall rules by each team without user role separation. Answer. Correct answer. B. Explanation. NSST provides highly granular RBAC, allowing roles to be customized per object and user group, supporting least privilege models. Option B falsely claims only 2 roles exist, which limits flexibility. Delegating all access control to vCenter C is inaccurate, as NSST has its own RBAC system. Manual rule configuration without role separation D is impractical and insecure. Question 20. At the heart of this issue lies the challenge of integrating NSST with existing physical infrastructure while maintaining security and scalability. How does NSST's bridging capability best facilitate this integration without compromising overlay network principles? A. It bridges specific VLAN-backed segments to overlay segments using Layer 2 bridge that preserves encapsulation boundaries. B. It merges all physical and logical networks into flat Layer 2 domain to simplify management. C. It disables the distributed firewall on bridge segments to reduce latency. D. It converts all overlay traffic into VLAN traffic, eliminating the overlay entirely. Answer. Correct answer. D. Explanation. NSST's bridging connects VLAN-backed physical segments to overlay segments at Layer 2, preserving encapsulation boundaries and security policies is the correct description. Option D incorrectly states it eliminates overlays by converting all traffic to VLANs, which negates NSST benefits, flattening networks. B reduces segmentation, disabling firewalls. C compromises security. Question 21. When evaluating the merits of deploying NSST distributed firewall in a multi-hypervisor environment, an administrator notes that firewall policies can be enforced at the VM kernel level on both SCSI and KVM hosts. What is the primary advantage of this architecture for securing east-west traffic in virtualized environments? A. It centralizes firewall processing on an NSX manager, simplifying rule updates. B. It eliminates the need for physical firewalls, reducing network complexity and latency. C. It offloads firewall processing to physical network switches for higher throughput. D. It enforces microsegmentation directly at the hypervisor kernel, minimizing traffic happening. Answer. Correct answer, D. Explanation. NSST's distributed firewall operates at the hypervisor kernel level on each host, providing granular microsegmentation and preventing unnecessary traffic happening through centralized devices, thus reducing latency and improving security. Centralizing firewall processing on the manager A is incorrect since the manager handles configuration, not traffic. Offloading to physical switches C doesn't align with NSST design. Eliminating physical firewalls B is an outcome, but not the primary architectural advantage. Question 22. Considering the evidence of persistent routing loops in an NSST environment, which configuration mistake is most commonly responsible for such behavior when using BGP is the routing protocol between Tier 0 routers? A. Enabling route redistribution between Tier 0 routers without proper route filtering or loop prevention. B. Configuring BGP peering only on Tier 1 routers, ignoring Tier 0 relationships. C. Assigning overlapping IP subnets to Tier 1 logical switches. D. Using static routes instead of dynamic routing protocols between Tier 0 and physical routers. Answer. Correct answer. A. Explanation. Routing loops commonly occur when route redistribution between Tier 0 routers lacks proper filtering or loop prevention mechanisms in BGP configurations, causing advertisements to circulate endlessly. Peering only on Tier 1 routers B does not directly cause Tier 0 loops. Overlapping IP subnets C can cause routing issues, but not necessarily loops. Using static routes D avoids loops by definition, but reduces scalability. Question 23. In terms of host preparation for NSST, which prerequisite is essential to enable overlay networking and distributed routing on an ESXi host? A. Installing the NSST VIP package to extend the ESXi kernel with NSST modules. B. Assigning static IP addresses to VMS before adding them to logical switches. C. Configuring VLAN trunks on the vSphere distributed switch exclusively. D. Disabling VMware vShield endpoint for compatibility. Answer. Correct answer. A. Explanation. The NSST vSphere installation bundle is necessary to add kernel modules for Geneva encapsulation, distributed routing, and firewall functions. Assigning IPs to VMS B is unrelated to host preparation. VLAN trunks C relate to physical or virtual switch configuration, but not directly to host preparation for overlays. Disabling vShield endpoint D is not required for NSST deployment. Question 24. Within the framework of NSXT logical routing, what is the key difference between Tier 0 and Tier 1 routers in a typical deployment? A. Tier 0 routers connect to the physical network and provide north-south routing. Tier 1 routers manage east-west routing for tenant workloads. B. Tier 0 routers handle distributed firewall rules, while Tier 1 routers only perform switching. C. Tier 1 routers directly connect to physical routers. Tier 0 routers only connect virtual machines. D. Tier 0 routers are deployed only in KVM hosts, while Tier 1 routers exclusively on ESXi hosts. Answer. Correct answer. A. Explanation. Tier 0 routers act as gateways connecting NSST to the physical underlay, handling north-south traffic. Tier 1 routers provide distributed routing for tenant virtual networks, managing east-west traffic among workloads. Firewall rules B are applied through distributed firewall, not linked to router tier distinction. Physical connectivity for Tier 1 routers C is false. Deployment based on hypervisor D is incorrect. Question 25. The implications of insufficient MTU configuration in an NSST overlay network are frequently observed as degraded performance or dropped packets. Why is configuring a higher MTU on the physical network crucial when using NSST overlay segments? A. Overlay encapsulation headers increase packet size, requiring higher MTU to avoid fragmentation. B. Larger MTU values increase CPU edge on hypervisors, leading to slower network throughput. C. MTU size is irrelevant because NSST compresses packets before sending them over the overlay. D. NSST overlay segments use VLAN tagging exclusively, which requires higher MTU on physical switches. Answer. Correct answer. A. Explanation. NSST uses of encapsulation. Adding approximately 50 bytes overhead to packets, the physical underlay must support a larger MTU, typically 1600 plus, to accommodate encapsulated packets without fragmentation or drops. Larger MTU does not inherently increase CPU edge. B. NSST does not compress packets. C. VLAN tagging. D. Does not explain overlay MTU requirements. Question 26. By evaluating NSST integration with vSphere, what is the role of vCenter server in an NSST environment? A. vCenter provides the virtualization infrastructure management but does not handle NSXT network configuration. B. vCenter is the sole controller of NSST logical switches and routers. C. vCenter handles all NSST security policies, including distributed firewall rules. D. vCenter replaces NSST manager when managing overlays. Answer. Correct answer. A. Explanation. vCenter manages the virtualization infrastructure such as hosts and EMS, but NSST manager handles network virtualization, logical switches, routers, and security policies. NSST functions independently of vCenter's network configuration. NSXT manager is the controller for network elements, not vCenter. B. Security policies C. are managed by NSXT manager. vCenter does not replace NSST manager. D. Question 27. From a practical standpoint, how does NSST ensure high availability for its edge node appliances? A. By deploying edge nodes in clusters with active-active mode using the built-in load balancer. B. Edge nodes do not support high availability and require manual failover. C. NSXT edge nodes rely on vSphere Hub for automatic recovery without cluster configuration. D. Edge nodes must be deployed on physical servers to guarantee availability. Answer. Correct answer. A. Explanation. NSST supports edge node clustering in active-active mode, enabling load balancing and failover for north-south services. Manual failover. B. is inaccurate, relying solely on vSphere Hub. C. is insufficient for service level Hub. Edge nodes are virtual appliances and do not require physical servers. D. Question 20. Within the framework of logical switching, what role do VLAN-backed logical switches play in NSST, and when should they be used? VLAN-backed switches provide integration with existing physical VLANs and are used when physical network segmentation is required. B. VLAN-backed switches replace all overlay switches to simplify the environment. C. VLAN-backed switches are deprecated and not recommended in any NSXT deployment. D. VLAN-backed switches enable microsegmentation by applying distributed firewall policies. Answer. Correct answer. B. Explanation. VLAN-backed logical switches allow physical VLANs to be managed within NSST, enabling integration with existing networks. However, they do not replace overlay switches but coexist for legacy or integration scenarios, not simplification. B. is incorrect. They are supported and not deprecated. C. Microsegmentation is achieved via distributed firewall regardless of switch type. D. Question 29. Examining the consequences of misconfigured routing protocols in NSST, what effect does incorrect BGP authentication configuration between Tier 0 routers have on network stability? A. It can cause BGP sessions to fail to establish, leading to loss of routing information and connectivity issues. B. It increases routing protocol performance by reducing unnecessary session renegotiations. C. It allows Tier 1 routers to automatically route traffic through alternate paths without delay. D. It has no effect, but DGP authentication is optional in NSXT deployments. Answer. Correct answer. A. Explanation. BGP authentication ensures secure neighbor sessions. Incorrect authentication causes BGP peering failure, leading to route loss and traffic blackholing. It does not improve performance. B. Nor enable automatic routing by Tier 1 routers. C. While optional, disabling authentication. D. Is insecure and can expose the environment to attacks. Question 30. To better understand NSST backup strategies, which method is recommended to ensure consistent recovery of the entire NSST configuration including managers, controllers, and configuration data? A. Using the built-in NSXT Manager backup utility to export encrypted configuration files to external storage regularly. B. Relying on vCenter server snapshots to capture NSXT Manager state. C. Manually backing up individual JSON files from the NSST CLI. D. Exporting only firewall policies and reconstructing logical switches and routers after failure. Answer. Correct answer, D. Explanation. The recommended method is to use the NSST Manager's built-in backup utility that exports encrypted configuration files containing the entire NSXT configuration consistently. Snapshots, B, are insufficient for disaster recovery. Manual JSON backups, C, are error-prone, exporting only firewall policies. D is incomplete and will not restore full configurations.